Hi students. Today we are going to discuss one more topic from the polynomials chapter, which is factorization of polynomials. Okay. So what do you mean by factorization of polynomials? So first we studied one topic called remainder theorem, where in remainder theorem you have to substitute the value of x. So how we substituted the value of x? We have taken the divisor and we equated divisor to 0 and we got the x value. That x value we substituted in p of x, which is dividend, and whatever the remaining term or a constant which is remained, that we call it as remainder. So in this the procedure remains same, but here you should understand one thing. Just I'll explain this factorization with an example, and before that you should know what is a factor mean. Factor mean, for example, we call 3, for example 6 is there, 6, 9, 12 are the factors of 3. How can we say that they are factors of 3? Because 6 can be divided by 3. Correct? We can divide 6 with 3, which will give you 2. Obviously, if 6 is divided by 3, obviously this 6 should be a multiple of 3 also. I hope you understood what I said. 6 can be divided by 3. If 6 can be divided by 3, the 3 should be by multiplying like 3 to 2, you will get 6. It means any number which is divided by one number, that number multiple will be the number which we divided. Okay. So factor in the sense, this we can say that 3 is the factor of 6 because exactly divisible, 6 is exactly divisible by 3. Okay. So that is the reason it is factor of 6. So similarly, how can you say this is the factor of a polynomial p of x? It's a very simple method. Carefully listen. First, we have to check whether x plus 2 is the factor of x cube plus 3x square plus 5x plus 6. So similarly, by dividing this polynomial by x plus 2, if exactly divides, means, for example, if you divide x cube plus 3x square plus 5x plus 6 with x plus 2, we know division of polynomials. With that method, if you divide this with this linear polynomial, if you get 0, then that is considered as factor. That is one way by division. So that will be a long process. So what we can do is, here we just consider the divisor, which is the divisor here x plus 2, because we have to check x plus 2 is a factor of the polynomial given as well as 2x plus 4. So which we have to prove it is a factor x plus 2. First equate that to 0. Okay, like we did in the remainder theorem. So x is equal to this minus plus 2 will become minus 2 when you send it to the RHS. So now in the p of x is equal to your dividend. What is the dividend polynomial? X cube plus 3x square plus 5x plus 6. This is the dividend we assume. So which is p of x. Correct. We assume it as p of x, and wherever x is there, you substitute minus 2. Got it? When you substitute minus 2, what do you get? Minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6. Correct? So what is minus 2 whole cube? Which is minus 2 into minus 2 into minus 2. So minus 2 into minus 2 is plus 4, and plus 4 into minus 2 is minus 8. So you will get minus 8 plus 3 into minus 2 whole square, which is 3 into 4, which will give you 12. Right? And 5 into minus 2, which is minus 10 plus 6. So minus 8 plus 12 is same as 12 minus 8. 12 minus 8 is 4, and minus 10 plus 6 is minus 4. So what do you get? 0. Remember, when you get 0, when you substitute this x value, the polynomial p of x, if you get 0, then we can say that that polynomial, that linear polynomial is considered as a factor of the given polynomial. Okay. So similarly, we have to check whether 2x plus 4 is also a factor of the given polynomial. So how to check? We just go with the easier method. The same way, we just consider 2x plus 4 is equal to 0. I'll just do here. Okay. First step, you have to equate 2x plus 4 equal to 0. Correct? When you equate 2x plus 4 equal to 0, you will get 2x is equal to minus 4. X is equal to minus 4 by 2, which is minus 2. Correct? 2 ones are 2 twos are. Correct? So, when you divide, obviously this cancellation part, I hope you understood. 4 with 2, 2 twos are 4. So, x value we got it as minus 2. So, substitute minus 2 in the place of x. Okay, when you substitute minus 2 here, okay, here if you observe, we have the same thing, 2x plus 4, when you equate to 0, we are getting minus 2. Similarly, we read x is equal to minus 2. Isn't it? Both are alike, means both are same. So when you substitute minus 2, same thing what we got here, minus 2 whole cube, 3 into minus 2 whole square, plus 5 into minus 2 plus 6. And see the same simplification I get here. You will get 4 minus 4, which is 0. Correct? See, here also x is equal to minus 2. When you send that, 2x plus 4 is equal to 0, and when you send that plus 4, you will get minus 4. And there also you got x is equal to minus 4. Both are same, factors. Understood? So both the cases you got 0. Then what we can conclude? We can conclude that 2x plus 4 and x plus 2 are the factors of the given polynomial. Okay? Now I'll just explain once again. Here, examine, see this question given is examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus c and of 2x plus 4. It means here two linear polynomials are given. What is that? X plus 2 and 2x plus 4. We have to check whether these two linear polynomials are factors of the polynomial given x cube plus 3x square plus 5x plus 6. First step, what you have to do? First you equate the x plus 2 because this should be a factor of this. So this here, a linear polynomial always we should take. Remember, we have to take always linear polynomial. So x plus 2 is equal to 0. Equate that to 0. And what is the x value? Send this plus 2 to that side. RHS you will get minus 2. Wherever x is there, this you take it as p of x. Let p of x is equal to the given polynomial. Wherever x is there, substitute minus 2. So here what I did, in the place of x, I substituted minus 2. What do you get? Minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6. So minus 2 whole cube is minus 8 and 3 into minus 2 square is 4. So 3 into 4 is 12 and minus 5 into minus 2 is minus 10 and 6 constant you take as it is. So 12 minus 8, 4 minus 10 plus 6, 4. So 4 minus 4 is 0. When you get 0, then we can conclude that x plus 2 means whatever the linear polynomial you have taken, x value you have taken, that can be considered as the, means here x plus 2 can be considered as a factor of the polynomial. Similarly, 2x plus 4 I equated to 0 and I got 2x is equal to minus 4 and x is equal to minus 4 by 2 which is minus 2, same value we got. What we got before, same value, again I substituted so that I got 0 as the answer. So when you got 0 there, even we can say the 2x plus 4 is also considered as the factor of the polynomial. Okay? Yeah, just we will move to the next sum. What it is? Find the value of k if x minus 1 is the factor of 4x cube plus 3x square minus 4x plus k. Here, this is a sum where you already they just given that they only given that x minus 1 is the factor of this given polynomial. Okay, and we know the condition that if any polynomial, linear polynomial, if x minus 1 is a factor of the given polynomial, then when you substitute x, whatever x minus 1 is first, what is the first condition we should do? We should equate to 0, correct? The same thing what I followed for the last sum, the same steps I am following. X minus 1 we should equate to 0 and x is equal to 1. So you got x value as 1. So now when you substitute the value of x in a given polynomial, if that value, whatever you get after the substitution of x value, if that is 0, then only we can consider this x minus 1 is a factor of the given polynomial. Yes, now what is the question here? Find the value of k if x minus 1 is a factor of the given polynomial. It means they are already given in the sum that x minus 1 is a factor of that given polynomial. Understood? If this x minus 1 is a factor of the given polynomial, it means x is equal to 1. When you substitute x is equal to 1 in this polynomial, that should be equal to 0, isn't it? So what we do, wherever x is there, let p of x is equal to the given polynomial. What is the p of x? Just p of x is, we assume it as 4x cubed plus 3x square minus 4x plus k. I'll just continue there. Here x is equal to 1. So whenever you substitute x as 1, it should be equal to 0. Because since, you can write here, since x minus 1 is a factor of p of x, correct? If x minus 1 is a factor of p of x, since x minus 1 is a factor of p of x, your p of 1 should be equal to 0. That is the condition. So substitute in the place of x 1. So what will be p of 1? 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. That is your p of 1. What I am doing, wherever x is there, I am substituting x value as 1. So that same I did here. 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. So what value you will get? You will get it as 4 into 1 cube. 1 cube or 1 power any number, which will give you 1. 3 into 1 square, again 3 into 1, 3 minus 4, isn't it? 4 into 1 plus k. Got it? So can I cancel 4 plus 4 and minus 4? You will be left with 3 plus k. Got it? So you will be left with 3 plus k. We should equate p of 1 to 0. That is the reason 3 plus k is equal to 0. And if you observe here, we just send that plus 3 this side. So k value is minus 3. Got it? So we got k value as minus 3. Okay? I'll just explain this sum once again. Listen. Find the value of k if x minus 1 is factor of 4x cube plus 3x square minus 4x plus k. Okay. In the sum itself, it is given x minus 1 is the factor of the polynomial. It means what we did in the last sum, if any number linear polynomial is a factor of the given polynomial, we should equate that linear polynomial to 0 and find x value and you substitute in that polynomial. If you get 0, then it is a factor of the polynomial. So they, in the sum itself, they are telling it is a factor. It means what? Whenever you substitute x is equal to 1, that should be equal to 0. Correct? Because they only given it in the sum. So now x minus 1, I just equated to 0 and we got x is equal to 1. So wherever x is there, you substitute 1. Because since x minus 1 is a factor of polynomial p of x. What we assume p of x? 4x cube plus 3x square minus 4x plus. So now when you substitute x as 1, what we got? 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. So 4 into 1 cube is 1. So 4 plus 3 into 1 square, again 1 square is 1. 3 into 1, 3 minus 4 into 1, 4 plus k. 4 and minus 4 both will get cancelled. You will be left with 3 plus k. So we have to equate p of 1 to 0. So that's the reason we are equating 3 plus k equal to 0. And just you send that 3 to the other side, RHS, you will get k value as minus 3. So what is the k value? Minus 3. Okay? Yeah. Yeah, I hope you understood that. Next we will move on to the next concept. It is factorization. Okay? How to factorize the given polynomial. There is a concept called splitting the middle term, which is very important for your 10th standard also, because this same concept will be continued in the 10th standard. Means you should know how to split the middle term. I'll explain here with the help of a sum. Just listen to that. Factorize 6x square plus 17x plus 5 by splitting middle term. Okay, what is this splitting middle term mean? Okay, so carefully observe here how to do this splitting middle term. Okay, so here first just take down the sum polynomial given 6x square plus 17x plus 5. Correct. So now here first this is called x square coefficient, which is multiplied with x square, and 17 is called x coefficient, and this is a constant term. First, always you just equate this with a common notation ax square plus bx plus c. So CA, if you multiply the constant term and x square coefficient, we'll get CA. Alright, and here middle term is B. For example, here, what is the last term here? Constant 5. What is the x coefficient? 30. So I'll just remove this. We should get, just multiply the last term with the first term of polynomial. What do you get? 30. Correct? Alright, so when you multiply the constant with the x square coefficient, you will get 30. Right? What is the middle term here, which is x coefficient? 17. Okay, I'll just explain once again. The constant term 5, here constant is 5, and what is the x square coefficient? Always this will be the same for all the problems which are of the splitting middle term type. So you multiply the constant with the x square coefficient, which is 5 into 6. What we got? 30. So what is the middle term, which is a coefficient of x? 17. So you should take two numbers in such a way that if you multiply those numbers, okay, if you multiply those numbers, you should get the 30. Okay, you should get 30. When you add or subtract, you should get 17. So the two numbers which you are going to take, they should satisfy these two conditions. So here I just assume one number as 15, the another number as 2. Correct? So when you consider 15 and 2 are those numbers, just you find it out, 15 plus 2, you will get 17. Correct? And 15 into 2, you will get 30. I'll just write this here. 30, 17. If you take 15 and 2, don't just give some space or put like unsymbol, otherwise it will become 152. So 15 is the first number and 2 is the second number. So 15 and 2 we are considering. Correct? So 15 plus 2 will give you 17 and 15 into 2 will give you 30. This is how you have to take the terms. Here you observe 6x square in the place of the middle term. Okay, 17x, just 15 we got and 2 we got, just you multiply with x. That's all. First you take it as a number, then you just multiply with x. So 15x and it will become 2x. And only what I am doing here, if you observe, 5 as it is, 6x square as it is, only middle term I changed. Correct? So it is logically 17x I am writing as 15x plus 2x. It is correct. Correct. So that is the reason it is called as splitting middle term. Only middle term I split it. Okay. For this splitting, we did this kind of procedure. So 15 plus 2, 15x plus 2x plus 5. So now here we have to take common factor out. Understood? Here 6x square plus 15x, I'll take it as 3x as common. Okay. For example, in 6x square, the 6x square can be written as 3x into 2x. Is it right? So 6x square can be written as 3x into 2x. When I take 3x out, what will be remaining? 2x. Correct? Understood? So now, similarly, 15x is there. In that 15x, can I write this 15x as 3x into 5? Because 3 5 is 15, 15 into x. So when I take 3x common, what will be remaining? 5. So plus 5. Here if you see, already we have 2x plus 5. Can I write this 2x plus 5 as 1 into 2x plus 5? Correct. Because any number or any term which is multiplied with the 1 will get the same term. It doesn't, there is nothing wrong in that by writing 2x plus 5 into 1. Okay. So now here see 3x into 2x plus 5 plus 1 into 2x plus 5. In this both terms you have 2x plus 5 common. So take 2x plus 5 common. What do you get? You will get 3x plus 1. Okay. If I take 2x plus 5 common, here also it is there. See, remember, if you want, whenever you are taking common, that term should be there in both the, like both, you see 2x plus 5 is a multiple of 3x as well as 1. Then only you can take common. For example, 3x plus 2x plus 5 is here, and here we do not have 2x plus 5 common. We cannot take common. It has a common factor. It is not possible. It should be there for both the terms. So here if you observe 2x plus 5 is there multiplied with 3x also, it is multiplied with 1 also. So take 2x plus 5. What is the multiple of 2x plus 5 here? 3x. Middle symbol is plus, and again here 2x plus 5 multiplied term is 1. So 3x plus 1. This is how you have to factorize using the splitting of middle terms. See, very, very important topic it is. Okay. Anyway, I'll explain. Yeah, I'll explain one more sum of the same type. Okay. Factorize x square plus 2x plus 1 by splitting the middle term. This is of the same type what we did the last term. So here first you write the polynomial which we have to factorize, x square plus 2x plus 1. Now what is the middle term? Middle term is nothing but coefficient of x, which is 2 right here. And I written see this. By adding or subtracting, you should remember, by adding or subtracting you should get 2. Okay. And what is the constant term? Last term is the constant term 1. And what is the coefficient of x square here? Don't take the coefficient of x square coefficient. So 1 into the coefficient of x square, which is 1. So 1 into 1, which is 1. So multiplying you should get 1. By adding or subtracting you should get 2. So now you should take two factors in such a way that you should get 2 by adding or subtracting, you should get 1 by multiplying them. So that's the reason I taken 1 and 1. Got it? When I take 1 and 1, 1 plus 1 you'll get 2. See, by adding you are getting 1 plus 1 2. So which is this condition satisfied. Now 1 into 1 you should get 1. So we are getting 1. So what we can take? We can take 1 and 1 are the factors of the given middle term. So 2x in the place of 2x, see x square I am retaining as it is, 1 I am writing as it is. Only in the place of 2x I am writing 1x. See, whenever you are writing what I said, just you multiply with x. 1x plus 1x. So here we got x square plus x. So what is the last term here? X square. So x square can be written as x into x. Correct? When I remove x, when I take one x out, you will be left out with x. Similarly, in the one x, if I take x out, you will be left with 1. So 1 into x. If I take x out, you will be left with 1. And here already we have x plus 1. 1x plus 1 is same as x plus 1. So 1x plus 1 can be written as 1 into x plus 1. As we know that any number multiplied with 1 is the same number. So x plus 1 can also be written as 1 into x plus 1. So here x plus 1 we have, here also we have x plus 1. So here what is the x plus 1 multiple? X. Here what is the x plus 1 multiple? Is number multiplied with 1. So take x plus 1 common. Remember, you can take common if both terms are same in this. If both terms of this multiples are same, then only you can take common. Otherwise, if here you have x plus 1, there you have x plus 2, you cannot take common. Remember, you should take when both the multiples of the terms or both the terms are same, then only it is possible. So x plus 1, if you take common, what is the multiple of x plus 1 here? X. So right. What is the middle symbol? Symbol we have plus, right? Okay. And here, what is the multiplied x plus 1 multiplied with 1? So take 1. So we factorize it as x plus 1 into x plus 1. So this is how you have to factorize the given polynomial.